then it's not even recording.
Hi, Yancy.
I don't think so.
Hi, Yancy.
All right, 11.6. I think you guys have your heading up there, so go ahead and put the heading. I don't have, well, it's, the one that I usually have is low on batteries, so I'm just going to try and, we'll see how well it picks it up. I should probably move this more over there. Yeah, I know, there's going to be a lot of pauses because I usually just keep talking. So I'll kind of keep it right there. Try and move it as close as possible. You guys have a little cord thing, right? Okay. Bless you, bless you.
Bless you. Thank you.
All right, so the first little, I don't know if they call it theorem today. Yeah, the first theorem is going to be, I just put chord on it. I didn't put theorem or anything else on it, just chord, so you can kind of remember it a little easier. Let's see, it says if two chords intersect inside a circle, then the product of the lengths of the segments of the chords are equal. That sounds a little bit confusing, but it's fairly simple. I'm going to draw two chords in here. I'm going to try and draw them with different colors, actually. Okay, so there's your two chords. We're going to put letters on this thing to help us identify these. So I'm going to call one A and B, C and D. And let's call the middle one the letter D. I do know for a fact you will see this. You probably will see this on the state test. They do give you circles like this with these chords in here, so you kind of need to know what to do with them in order to be able to get an answer. Okay. So a chord is just a line segment that's inside a circle that doesn't go beyond the circle, right? It stops right there, it stops right there, it stops there, it stops there, and that's all it is. And so here's what this theorem says in a nutshell. Okay? In a nutshell, it just says, let me get I should use the pen. It says that this times this is equal to this times this. Does that make sense? So AE times EB. Let's just say AE times EB. I'm going to put little segments like that, okay? Just so you know. Is equal to the same thing as this, CE to EB. I should probably write it this way, to make it less confusing. Okay. So if you know like three numbers and you have one missing, then you can find out what that little missing segment is. That's basically what you're going to be doing right now. You guys have that one on here? Oh. Okay, so again, if you put, let me give you some numbers, just kind of put these in there. Hopefully you're no, like let's say make this a 6, an 8, and this a 4. I can find out what this one is right here. You would do 6 times 4, and then you would do 8 times x. So you wouldn't know what that is. And so that one would be 3, right? You divide by 8, and you're done. That's all this is. But you gotta need to remember it though, because they're not gonna give that to you on a test. Okay. Go ahead and find out the missing variable for the separator, the x. It is very easy, but what's not easy is when you're taking your test and you have 100 million things to remember, and this is like one of those little last things that you're probably gonna, what was it? Hopefully you remember. It's pretty easy. What's the answer? Okay, I'm assuming we know how to fix this up. 14 times x equals 10 times 7. I heard 5, right? Alright, great. 5. Okay, this is a secant. That's what I'm going to call it. This is a secant theorem. So I'm going to explain what this is. Rather than give you a really, really long theorem that the book gives you, I think it's easier to just see it with a picture. And then you'll understand what this is right here. Because it basically says pole times the outside equals pole times the outside. Okay, so you'll see what that means right now. Yeah, I draw these lines, the two secant lines that you have. You just have a circle on yours. Go ahead and draw the secant lines. And then we're going to go ahead and label this thing too. And I'll give you guys a second to copy because I think I'm going kind of fast. And this lesson's pretty easy, pretty short. We have one on how to graph circles, which is kind of really short. And then I just need to talk to you guys about transformations. And then that'll be it. Then we'll review the rest of the time we have. We have to. Yeah. I'm still waiting for I emailed the counselor, and so I'm still waiting for her to email me back to see what she says. I hope they can just do teacher recommendation. Yeah. For Katie? For Colony. Do you have a name? Yeah, like a letter or. Ramiro Hernandez.
That. Marco.
Yeah, it's just gonna be a long video. So.
Sounds like they're recording.
This week, right? Let's go on the question.
Yeah.
They're gonna come on Friday. Why are they coming on Friday if we're gonna get out early? Hey, better for us. We got less time if we have time. Friday we're coming out early. Oh, because open house is on. Oh,
All right, guys, back over here. Back and front. Secant, secant. So we did chord, chord. Now we'll do secant, secant. Secant, secant is basically secant, secant is basically taking the whole. See, it says whole times the outside, so basically it's AE, whatever AE is, times BE equals CE times CE. Okay, so the whole times the outside equals the whole times the outside. That's how that works. So if you want to write down those variables, basically it's AE times BE. The whole times the outside equals the same thing as the whole, which is CE, times DE. It's very easy, obviously, to solve it, but it's just remembering what to do. Because I don't, you may confuse yourself and you may say, oh, is it the whole times the inside, or is that's the only thing that I can imagine happening to you if you're like looking at a problem like this and you're just stuck and I don't know what to do with these numbers.
Wait, so you just add.
So it's
you would
just
add the numbers.
yeah. Usually, like if they give you like a 10 and a 4, then you would say 14 times 4 equals something times something. If you only give you one other number, okay, you'll see. Did I give you an example?
Yeah.
I gave you two actually. Go ahead and try and use that same technique I just showed you. But
they're in the inside.
yeah, you're right. Let's look at one of them. Okay, so you know that to do secant secant, it's the whole. Which these in the hand for me. Oh, it's really looking at this thing and be like, huh? Huh? Okay, I guess I'll show it first. So whole. So this would be, how would I write the whole if it says x and an 8?
8x.
Not 8x. 8 plus x, or you can say x plus 8 for the whole, because it's not 8x. Remember, 8x would give you the wrong number. So whole is going to be, you could say x plus 8 like that, times the outside, which is 8, yeah, equals, so whole times the outside. What's the whole for the other one? 16 times the outside, which is 7.
So even though it's inside, still add it?
Even though what's inside? But see, the whole would be from here all the way to here, and so you have to add both of them. Solve that for me. I want to distribute. I would first multiply those two over there. And then instead of distributing this, I would divide by 8. And then at the very end, just subtract by 8. Otherwise, you're going to get a big number. You're going to get 8x plus 64. That's going to be... Okay, I overheard someone saying, is this supposed to also add up to 16? It's not. It could be a different length, remember, because these are they're touching at different spots, so they're not going to be identical. Okay. What's this over here? 16.
It's 121.
What is it?
112.
112. Who's going off what she said? Hold on. 112, x is 8, times 8, divide by 8. I'm going to divide by 8 there. 14. 14. That's it? 6. Good. Did you solve the other one? Try the other one real quick. Just for practice. We only have one more actually left, so this is a pretty short lesson. I'll show you right now how it's shown on state question. It's very similar. They literally give you a picture just like that, and it's pretty straightforward. Like you just gotta use the same little formula. Okay, it's nothing fancy. These are huge numbers, huh? Hmm. You're smart. You're probably dividing by 13. You divide by 13 first, and you get 3. Then what's 3 times 9? You didn't do it that way? You did 13, 39 times 9 first? And I would have done it this way. I know it's not order operations, but I would have done it this way. And it's shorter number. Smaller. Yeah. 13. So there's many ways to solve this, obviously. I'm showing you just a different way. I got 14. Finish with the problem. We're going to do the last one here. So we've done chord, secant, secant. Secant tangent. What's a tangent line? The one that touches what? Touches once, right? So tangent just means it barely touches once. Down here. A secant is the one that goes through the circle. You guys don't have. Do you have the circle? No, you don't. Oh, you have the circle. Go ahead and draw those two lines for me. I'm going to explain it rather with words. I'm going to explain it just by showing you with the actual picture, okay? So that's why I didn't really write much there. This is the last one. If the secant and a tangent intersect outside a circle, let's label this. I should probably make mine fit. There it is. A, B, C. Let's call this one D. What do you think it is? You got a whole one here, and then you got part of one. Same thing, kind of. It's going to be the whole times BC. So it's going to be AC times BC. That one's still the same, kind of like the last one we did. Oh, not AC. Yeah, okay, so it's the whole times the segment again. AC times BC equals, and here's a different part. This is the only one that's different. It is CC, but it's squared. So this one right here, squared. Anyways, try and do the two on your own, guys. Use the same. Use it. What I just gave you.
Alright, hey.
Use what I just gave you. Basically, plug those numbers in just the way that they see there. Okay.
We put x squared.
Yes. That's what you're gonna do. What do you do with an x squared? Yeah, square root. Simple. Okay, so I'm going to use that. Let's see. The whole is 20 times the outside is 5 equals BC is x squared. It is square root x equals. How do you do the next one?
The next one is a decimal. Yeah.
That's it? Did I give you decimal?
Yes, it did.
I don't think I did.
Mm-hmm.
Yeah, you're right. The whole is what? 7. Y plus 7, you can say 7y. So the whole is 7y. Times the outside. I didn't realize what the hell it is. What is it? 51 over 7. Okay, then give me a decimal. I think it is a decimal word. What did I give you guys on Friday? Didn't I give you guys
No.
yeah, the back. Yeah. Why not? I didn't teach the back.
We had to back side? No. I didn't bring it as a problem. I left it in my geometry folder. I didn't drag it. Was it homework?
You were working on it in class. Well, you were working on it in class, right?
I didn't get these two.
I think the back is put up. If you have this, the back side is homework. There's only 6 problems. Not a lot.
Oh, it's right here.
Sorry. You guys got 10 whole minutes to do this, which I'm expecting you guys to. What is the answer here?
I got 10. Yeah, I got 7.
0.2?
Yeah.
Are you sure? Yeah, you're probably right. You're welcome. Told you. I wanted to show you guys how this works. Oh wait, that's not. No, I don't have. Then I had one that had in the state test. I think we're done recording.
Hi, Auntie.
Hi, Nancy.